Hi, I'm Sarah Morong, and I'll be talking about the Subaru telescope, which is a ground-based telescope located in Hawaii. First, we'll start by talking about the general facts surrounding the telescope. Now, first off, the telescope is affiliated with the National Astronomical Observatory of Japan, which is what the abbreviation NAOJ stands for, and it's also affiliated with the National Institutes of Natural Sciences, which is what the abbreviation NINS stands for. Another cool fact about the telescope is that it's based in Hawaii on the Hilo Base facility, and this facility, which was established in April of 1997, is so large that it houses many research labs, a library, and extensive computing facilities, including a supercomputer. Now, the telescope itself is located on the summit region of Mauna Kea, which is a dormant volcano on the Big Island of Hawaii. This is a huge deal and contributes to the utility of the telescope because clouds will not typically form above the summit. In other words, because clouds don't really reach above the telescope, it makes it a lot easier for the telescope to capture images of objects in the sky. Additionally, trade winds are able to blow very smoothly over the islands, making it so that the objects in the sky are, again, easily observable by the telescope. And as you can see in the picture to the right, this is the telescope shown way above the clouds, and this really shows how great of a location it's in because the clouds don't reach it, and that makes the images a lot more clear, and it makes the telescope a lot more easily able to capture images in the sky. Next, we'll focus on the specifications of the telescope, and one major fact about the telescope is that its primary mirror's diameter is around 8.2 meters, which translates to around 27 feet. Besides the Subaru telescope, there are only 3 other 8 to 10 meter class telescopes on Mauna Kea, one which is called the Gemini North Telescope, and 2 other Keck telescopes. In other words, this telescope is a little bit rare when it comes to the others on the island, and it's only one of 3 that fall within the size category. The mirror's thickness is around 20 centimeters, which translates into around 7.9 inches, and it weighs nearly 23 metric tons, which translates to the weight that almost 20 cars amount to. So the primary mirror alone, as you can see, is very, very heavy. And not only is the mirror heavy, but the telescope itself is incredibly heavy. As you can see in the slides, the weight of the structure of the telescope is 612 tons, which amounts to a ton of cars, way more than the primary mirror, and its height is 73 feet, which again is huge, and all these factors show how large of a telescope this is. And as you can see from the picture on the right, this is a picture of the primary telescope, or the primary mirror of the telescope, and as you can see, it's very large, very intricate, and can probably capture very intricate images. Next, we're going to be looking at the discoveries about the universe that have been made by the Subaru telescope. The first we'll look at is the star-forming region known as Sharpless 106. And through infrared images that were taken by the telescope, it was found that there is a young, high-mass star near the region's bright center. Additionally, it was found that there are many substellar mass objects in the region of Sharpless 106, and that the relative number of such objects differs greatly from place to place. Another thing that the telescope captured was a quote-unquote stealth merger of dwarf galaxies, where an infalling satellite galaxy is nearly undetectable by usual means, yet has a large influence still on its host galaxy. The telescope's high-resolution images also show individual stars and a dense stream of stars in the outer regions of a nearby dwarf galaxy. Lastly, the telescope has helped to survey the distribution of dark matter in the universe. In 2015, scientists discovered 9 large concentrations of dark matter in an area of 2.3 square degrees on the sky towards the constellation we know as Cancer. Because of the telescope's high imaging capabilities, many discoveries in our universe have been explored and studied in great detail. And each image correlates to each bullet point, so the one at the very top correlates to Sharpless 106. The one in the middle shows the stealth merger dwarf galaxies that I talked about, and then the last image on the bottom shows the dark matter that was captured by the telescope. And lastly, we'll talk about the concluding sentences of the telescope and how influential it was. It's mainly influential because of its location. I guess not mainly influential, but that definitely helps with how clear the images end up turning out, because clouds, as I said before, don't reach the summit of where the telescope is located. Also, as stated before, in the specifications slide, we saw how sizable and impressive the telescope is in nature. It weighed hundreds of tons, both the primary mirror and also the structure, and it was also 73 feet in height, so very, very large, and again, helps collect great images in detail. And lastly, we talked about the many discoveries that were made about the universe because of this telescope, and that's really why it's been so influential in our lifetime and why it continues to make discoveries and help us learn new things about the universe that we didn't previously know. And that's why the Subaru telescope is highly influential and why I was interested in talking about it today.